Welcome. In this lecture, we discuss about partial integral when x is equal to sine ax or cos ax. So, what is the particular integral? So 1 upon f of something d square is phi of d square, f of phi of d square sine ax is equal to 1 upon pi of minus a square sine ax. So in the last lecture, so what is the particular integral of this 1 upon pi of d square is equal to sine ax is equal to put d square is equal to minus a square here. A is this 1 upon pi of minus a square sine ax. So we find that in the last lecture when pi of minus a square not equal to 0. Pi of a square not equal to 0. But if pi of a square, pi of minus a square is 0, then what happens? If pi of minus a square is 0, then 1 upon 0. So that is infinity. So this method get fails. Which method? Yesterday we have to study how to find the particular integral. That method get fails here. So then what is the particular case? Particular case. Particular case. Okay. So if however the method get fails, the method get fails if what pi of minus a square is 0. That is how it happened. That is pi of d square. So this pi of d square is equal to d square plus a square psi of d square. If d square plus a square is the factor of this, and if we put d square is equal to minus a square, if we put d square is equal to minus a square, so d square is equal to minus a square, so minus a square plus a square, so that is 0. So this becomes here 0. If we put here d square is equal to minus a square, so minus a square plus a square 0. So this becomes 0. When it happens, if d square plus a square is a factor of pi of d square, then what is the particular integral here? So we find here particular integral PR. So 1 upon pi of d square sine ax is equal to put here pi of d square is equal to 1 upon d square plus a square psi of d square sine ax. Okay. Now we put here. So what happened? Put d square is equal to minus square. But we can't put here d square is equal to minus square, because minus a square plus a square is 0. So we put here d square is equal to minus a square. So this is what happened here. So 1 upon pi of minus psi of minus a square. And this is as it is here. 1 upon d square plus a square sine x. Okay. Here psi of minus a square not equal to 0. Doesn't matter. But we can't put d square is equal to minus a square. So what is this? What is this particular integral? So 1 upon d square plus a square sine x is what? So we have to find that. So consider. For that, consider here 1 upon d square plus a square cos x plus I sin x. We consider this is equal to what? is equal to 1 upon d square plus 1 upon d square plus a square. So what is this? Cos x plus I sin x. So this is the circular functions expression in circular functions. So we express this in terms of transcendental function e raised to ix. So this we have to study in complex number. So what is cos x plus I sin x is equal to e raised to ix. Okay, it's so very simple here. So now this equal to 1 upon d square plus a square. 1 upon d square plus a square e raised to ix is equal to what? So what is d square plus a square? We factorize this. So this is a d plus ia into d minus ia into e raised to ix. So what is this? A plus b into a minus b. So this is a square minus b square. So this is a d square here. D square minus I square a square minus I square a square. But I square is minus 1. So minus minus plus a square. So we can write this in this form here. So we factorize that. Okay. So now find, put here d is equal to I. D is equal to I. We don't know. So just see here. So what is the 1 upon f of d e raised to x? If x, capital X is equal to e raised to x, then what is the particular integral? E raised to x. So put d is equal to a. So 1 upon f of e raised to x, we get the particular integral. So what happened? Put d is equal to what? D is equal to ia. D is equal to a here. So d is equal to I. So that is ia plus ia. So we can't put here d is equal to ia because ia minus ia 0. So this is 1 upon d minus ia e raised to ix. Okay. So this is 1 upon 2ai. 2ai. So what is this? We directly write here. We have taken such types of examples many times. So we have to write directly. If the factor repeated 1 times, then what is the particular integral here? So this is e raised to ix into x divided by 1 factorial. Okay. So this what happened here? So this is okay. So this is equal to. So this is what? X e raised to ix x e raised to ix divided by 2ai. So we multiplying to numerator and denominator by I. So then what happened? I divided by I. So this is what? I x e raised to ix. Okay. So I square is minus 2a. So this is equal to. So this is equal to what here? So again we write this transcendental function in terms of circular function. So that is minus I x by 2 into bracket. What is e raised to ix? So that is cos x plus I sin ax. So this is equal to 1 upon d square plus just 1 upon d square just. So this equal to this here. This equal to this. Okay. So now comparing the real and imaginary parts. Just we start from here. Okay. We start from here. 1 upon d square plus a square cos x I sin x is this. So by comparing real and imaginary parts, so what is the real parts here? So 1 upon d square plus a square, 1 upon d square plus a square cos x. So this is the real part in left hand side. And what is the real part in the right hand side? So this what happened here? So this is I into I into I minus I into I minus I square, and minus minus plus. So that is x upon 2a sin x, and comparing the imaginary part of this. So 1 upon d square plus a square sin x is equal to what happened? So this is what imaginary part is here. So minus x upon 2a cos ax. So these are the standard formula here to obtain particular integral. So here just see here 1 upon d square plus a square. We find particular integral 1 upon 5 of d square. So this is this. Putting d square is equal to minus d square. And what is this? So this is equal to this. If there is cos x, then we get this. So this is a very simple method to obtain the particular integral when phi or psi of minus a square is 0. Okay. So we take example. So in this type, we taking examples. Then you get understand easily how to find the solution, or especially what is the particular integral is there. Okay. Example. Solve. Example. D square d2y by dx square minus 4y is equal to 2 sin x by 2. Solve this differential equation here. So solution, very simple example. So the given equation can be written as d square minus 4y is equal to 2 sin x by 2. Okay, by using operator. So what is the auxiliary equation? The auxiliary equation is d square minus 4 is equal to 0. Okay. So then what happened here? So d square is equal to 4. So d is equal to 2 minus 2. Okay. Taking square root of both sides. So these are the two roots of this auxiliary equation. So then first part is what is the complementary function? Okay. What is the complementary function? If the roots are different, then what is the complementary function? C1 e raised to m1x plus C2 e raised to, so this is m1. Okay. So what is the complementary function? C1 e raised to m1x plus C2 e raised to m2x. So what happened here? So this is equal to C1 e raised to m1 is 2x plus C2 e raised to m2 is minus 2x. So this is the complementary function. So what is the next part? Particular integral. Now Pi is equal to. Particular integral is what? So 1 upon f of d x. So what is the function here? 1 upon f of d. So what happened here? So this is f of d is this. F of d is this. So that is 1 upon d square minus 4. What is x? 2 sin x by 2. Okay. So how to find this? We know the method to finding the particular integral when 1 upon pi of d square sin x is equal to 1 upon pi of minus a square sin x. Putting d square is equal to d square is equal to minus a square. Okay, by using this, we put here what happened. So what is the coefficient of x? Coefficient of x is a. What is the coefficient of x here? So that is 1/2. So that is put d square is equal to minus a square. So a is what here? A is 1/2. So that is minus 1 half bracket square, a square, and then minus 4 2 sine x by 2. Okay, so this is what here? So that is 2 upon 1 by 4, so minus 1 by 4 minus 4 2 sine x by 2. So what happened here? So this is equal to, so this is what? 4 into 4 minus 16 minus 17 and 4 into 2 8. So minus 8. So 8 into 2. So that is minus 8 by 17. 8 by 17. 8 by 17 sine x by 2. Okay. So 4 into 4 16 minus 16 by 4 and then 8 by minus 17. So this is very simple. So what is the complete solution? Complete solution is what? Y is equal to CF plus particular integral PI. So what is CF? CF is C1 e raised to 2x plus C2 e raised to minus 2x plus P particular integral, this minus 8 by 17 sine x by 2. So this is the required solution of this differential equation. So we now solve another example to finding here the solution. Okay, so next example. Solve d square into bracket d square plus 1. D square plus 1 y sin x plus e raised to minus x. Okay. So what is the solution? The auxiliary equation is. So what happened here? D square plus 1 is equal to 0. Okay. So this is the fourth degree equation. So it has 4 roots. Fourth degree equation. D square into d square, fourth degree equation. So then what happened here? So that is d square is equal to 0. So d square plus 1 is equal to 0. Okay. Then d square is equal to 0 means d is equal to 0, 0. Then d square is equal to minus 1. So this is I square. Minus 1 is I square. So that is d is equal to, taking square root I minus I. So what are the roots here? 0, 0, I minus I. So these are the roots of this equation. Okay. So what is the complementary function? So what is the CF? CF is what? So first part of the complete solution here roots are repeated. 0 is repeated 2 times. So what is the complementary function? C1 plus C2x into e raised to m1x. Okay. So this is m1, m1, m2, m3. Okay. Then what happened? So that is C1 plus C2x into e raised to 0x. So that is e raised to 0, that is 1. Plus, if the roots are complex, so that is I and minus 1, then what happens? So alpha plus I beta and alpha minus I beta are the roots, are the complex roots. Then what is the CF? So that is e raised to alpha x into bracket cos something a cos beta x plus b sin beta x. Okay. So what is this? So what is I? I means 0 plus I. 0 plus I. I is equal to 0 plus I. So what is alpha? Alpha is 0 here. Alpha is 0. And what is beta? Beta is 1. So alpha is 0. Put alpha is 0. Alpha is 0. E raised to 0. That is 1. So that is we take C3 is the constant. Cos, what happened? Beta is what? Beta is what? Beta, alpha plus I beta. Beta is 1. Alpha is 0. So beta is 1. Cos x plus, we take another constant C4, sin x. So this is the complementary function. Okay, if the roots are like that. Okay. Now particular integral, now pi is equal to 1 upon f of d x. So what is the f of d? F of d is what here? 1 upon d square. What happened? 1 upon d square. So this d square plus 1. What is x? X is sin x plus e raised to minus x. So this is equal to. We separately apply those factors. So those operators. So that is d square plus 1 sin x plus 1 upon d square into d square plus 1 e raised to minus x. Okay, e raised to minus x. So this is a very simple example here. So put here. What is putting here? D square is equal to minus a square. D square is equal to minus a is here. Putting a is what? 1. So d square is equal to minus a square is here. Minus a square means a is 1. So this is minus 1. So we can't put here d square is equal to minus 1 because minus 1 plus 1 0. So this is as it is. D square plus 1 sin x plus. So put d is equal to, so just what happened here? 1 upon f of d. E raised to ax is equal to 1 upon f of a, e raised to ax. When x is e raised to x, when x is equal to sin x, then what happened? So if put d is equal to a, d is equal to a, put d is equal to 1, a is minus 1, minus 1, minus 1, minus 1. So then what happened? Minus 1 bracket square, minus 1 bracket square plus 1 e raised to minus x. Okay, so this is what? Minus 1 upon d square plus 1 sin x. So this is what? Minus 1. So this is 1 half e raised to minus x. Okay, so what happened? 1 upon d square. So we know that 1 upon, just we learn this formula here to obtain particular integral sin x. Sin x is equal to what? So that is minus x upon 2a cos ax, cos ax, cos ax. Okay, so by using this formula, so that is a d square, 1 upon d square plus 1. So a square is 1 here. Then what happened? So this is equal to minus x upon 2. A is what? A is 1. A is 1. So minus minus, this minus and this minus is plus. X upon 2 cos x plus 1 half. So we get here particular integral of this example. So what is the complete solution? Complete solution is y is equal to CF plus PI. So this is the complete solution. Then what is the complete solution? Y is equal to CF plus PI. What is CF? CF is this, put here. And particular integral is this, putting here. So we get the required solution. So it's a very simple example. Okay, we get the required solution. So we take another example. Solve d cube by dx cube plus y dx cube plus y is equal to cos x. cos ax. So the given equation is d cube using operator y is equal to cos ax. Okay, the auxiliary equation is, so what is the auxiliary equation? Is d cube plus 1 is equal to 0. So this equation can be written as d plus 1. Factorize this equation, d square minus d plus 1 is equal to 0. So that is a d is equal to, d plus 1 is equal to 0. So d square minus d plus 1 is equal to 0. So d is equal to minus 1. And so what is this? By using formula, this is a quadratic equation, the roots are, so d is equal to minus b. So minus b is what? Minus 1 minus 1 plus 1. 1 plus or minus. Okay. So what is this? B square is 1 minus 4 divided by 2. So this is what? This is what here? So that is 1 plus or minus 2. What happened? So root of minus 3. Root of minus 3. So root of minus 1 is I. So that is I root 3 by 2. So what are the roots here? D is equal to minus 1. 1 plus I root 3 by 2. And 1 minus I root 3 by 2 are the roots. Okay. So we find the roots of this equation. Then what is the complementary function? C1 is equal to, CF is equal to C1 e raised to m1x. So this is minus x plus alpha plus I beta. So what is alpha? Alpha is 1/2. Alpha is here 1/2. And beta is what? Root 3 by 2. Okay. Then what is the complementary function? E raised to alpha x. Alpha is what? 1/2 x by 2. So cos of beta. Beta is root 3 by 2. Root 3 by 2x plus sine something c2. Then c3 sine root 3 by 2x. So this is the complementary function. Now what is the particular integral? Pi. So what is the particular integral? So that is 1 upon f of d x. So what is the particular integral? 1 upon f of d is what? F of d is this. 1 upon d cube. Okay. 1 upon d cube. F of d plus 1. What is x? X is cos x. Okay. So this is equal to, what is the d cube? So this can be written as d into d square plus 1 cos ax. Then what happened? Put d square is equal to what? D square is equal to minus a square. Put d square is equal to minus a square. Okay. Then 1 upon minus a square. D square minus a square plus 1 cos ax. So then this equal to, what happened? 1 upon d into d square, that is d cube. Put d square is equal to minus a square. So this is 1 plus 1 minus d a square. So then we rationalizing, so multiplying by 1 upon plus d a square divided by 1 plus d a square. Why it is? Just see here, cos ax. Okay. So then this equal to 1 plus dA square divided by, what happened here? 1 minus dA square, 1 plus dA square, that is 1 minus dA raised to 4. A raised to 4 into d square cos ax. Then put d square is equal to minus a square. D square is equal to minus a square. So this equal to 1 plus dA square divided by 1 minus a raised to 4 into bracket minus a square cos ax. Okay, cos ax. So this equal to what happen here? 1 plus d square, dA square divided by, so this is what? 1 plus a square, a raised to 4a square, a raised to 6 cos ax. Okay, now apply this on cos x. So 1 into cos x is cos x. Okay, minus d of sin x. D of sin x is what? Sin x. Cos, derivative of cos x is minus sin x, and a square as it is, divided by 1 plus a raised to 6. Okay, a raised to 6. Therefore, this is the particular integral PR, and this is the complementary function. Therefore, the complete solution is y is equal to CF plus PR. Okay, CF plus PR. So we add complementary function this, that is CF, and the particular integral PR is this. We get the required solution. Okay, so we obtain here the complementary function and particular integral, and we get the complete solutions. So we see tomorrow the next type. Okay, when x is equal to x raised to m. Okay, thank you.